In this video we'll discuss about the introduction to gear trains. Okay, so this is the introductory chapter here about the gear trains. First we'll define what you mean by the gear. Okay, this is the gear. So if you come to the definition, a gear may be defined as a pulley or it is a wheel. Okay, it is a plain pulley or it is a wheel having projections on its rim known as teeth. Okay, just I'll give here one example here. This is the pulley. This is just like a pulley or wheel. It is a plane on the periphery. It's having a projections, just like a projections like this on its periphery. Okay, like this, totally on the periphery. So these projections are called as teeth. Okay, these teeth are helpful to transfer the power. Okay, this is how the gear may be defined. So before going to the gear, we have other types of the power transmission systems. One is, if you go to the belt drive, this is the belt drive, and second one is rope drive. Okay, so in case of belt drive, you have two pulleys here, one plain pulley and one more plain pulley, and that is these two pulleys are driven by a open belt or cross belt here. Okay, this is the open belt drive, as we studied in the previous sessions here. Even in the rope drive, the rope is the main material we are using to transfer the power from one pulley to another pulley. The main disadvantage of these two, the belt drive and the rope drive, is the slipping. Slipping is the common phenomenon, occurs in these two types of the systems here. Okay, because of the belt expansion or the rope expansion, it is the material, you know that the material is made up of the elastic type of the material. This is the reason the slipping may occur in the belt drive and the rope drive here. Okay, so next point is, because of the slipping, the velocity ratio will be reduced. So slipping will be the main criteria which affects the velocity ratio. Velocity ratio is nothing but the speed of the driver divided by speed of the driven here. Okay, that we will discuss in the later session or next session here. So velocity ratio will be affect on the slipping and it will be reduced. Okay, but whereas in case of the precision machines require the velocity ratio is very important. That is the main criteria. Velocity ratio will be the main criteria in the precision machines here. What to do to avoid the slipping here? Okay, so to avoid this slipping on the plain pulleys, gears are introduced here. Okay, so as I said, the gears are having the projections like the teeth. Projections like teeth. These will reduces the velocity ratio. Increases the velocity ratio and reduces the slipping here. Okay, that's why we are introducing the gears and gear trains in this chapter here. So if you go to the next point here, gear drive is used when the distance between the driver and the driven is very, very small. It means the both are interconnected, the very small, whatever the, suppose for example, this is one gear having certain teeth like this, and one more gear having again the external projections like this. Okay, whatever the center distance, for this is the center of the driver gear and this is the center of the driven gear. If it is very, very small, then only you can use the gear drive. This is one of the disadvantage of the gear drive. But whereas in case of the pulleys, the belt drive and the rope drive, even the center distance is far away, we can use the belt drives. Okay, so next the topic is the friction wheels. Okay, here the wheels we are considered as the plain wheels. They are not the gears. just like a wheels or pulleys. Okay. First, how the friction will occur between the pulleys we will discuss here. First, consider a plain circular wheels. We have two wheels here, one wheel and one more wheel. The first wheel is named as A and the second wheel is B. Okay. Wheel A and B having sufficient rough surface, whatever the sufficient rough surface, and pressed against each other. The whatever the surface is there, the pulley A, it is having a sufficient rough surface, and plane B also having sufficient rough surface, and they are pressed against each other. This is the picture here. Okay. Wheel A is keyed to the rotating shaft. Whatever this wheel is there, this is keyed to the rotating shaft. It means you are connected this shaft, whatever this shaft is there, you are connected to motor or shaft here. Okay. This is connected to rotating shaft, and wheel B to the shaft to be rotated. This to be B is connected to wheel A. Okay. Wheel A is connected to the motor or motor shaft, and B is connected to wheel A, as shown in figure here. Okay. The next point, wheel A is rotated by rotating shaft. As we know that the wheel A is rotated by rotating shaft, and will rotate wheel B in opposite direction. Obviously, see here, if for example wheel A, it is connected to motor, because of this shaft rotation, for example, the wheel A is rotated in clockwise direction, it will rotate in clockwise direction. Since wheel B is connected to wheel A, and this will be rotates in opposite direction, wheel B is rotated in opposite, that is anti-clockwise. For example, this will rotate in anti-clockwise. Okay. In case of both are interconnected here. Okay, that's only he is given this point here. Wheel B is opposite direction, it will rotates. So next point, so note that wheel B will rotating by wheel A. This wheel B is, we know that wheel B is rotating by wheel A. As long as these two are rotating, the B is rotating with respect to A, as long as the tangential force exerted by A. Normally, the tangential force exerted by A does not exceed the frictional resistance between the two wheels. Here the condition here, please focus on here, the tangential force. The tangential force is generated by wheel A. Okay, if this force does not exceed the frictional resistance between these two wheels. If this is the condition, then only wheel A and wheel B are in contact and rotated against each other. Okay. If the tangential force of wheel A, whatever the wheel A we saw here, that will be exceeds the frictional resistance between two wheels, then slipping may occur here. Okay, this is the cause of slipping. Remember, once again I'll tell, here the tangential force is generated by wheel A. Okay, so if this tangential force not exceeds to the resistance friction between these two wheels, then these two are interconnected and they are rotated in opposite directions. If this force exceeds, if whatever the tangential force of the wheel A exceeds than the resistance force between these two wheels, then slipping may occur here. This is the main cause of the slipping here. That is only he is given here. Slipping will take place. So to avoid the slipping, what we need to do here? We need to introduce the gears, and it is just like a gears we need to introduce, and it is having the outside projections, that is called as the teeth like this here. That is only he is given the last point here. To avoid this slipping, the number of projections, whatever these number of projections called teeth are provided on the periphery of the wheel A and B, both in wheel A and B. You need to introduce here both the projections on the periphery of wheel A and wheel B, so that you can avoid the slipping here, and thereby you can increase the velocity ratio. That is the reason we are introducing today's chapter is the gear trains here. Okay, only the advantage of the disadvantage of the gears are the center distance. You can directly, you need to connect the both very less center distance. This is the one of the disadvantage here. Okay, this is how the introductory unit here.